Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to talk about finding either x or z values when we know the area of a normal distribution. Up until now, we've been finding the area under the curve or the probability when we know either the z-score for a standard normal or an x-score for just any normal distribution. In this video, we're going to talk about the reverse of that. How do we find the z-score or the x-score when we know the area? So let's start with the standard normal first of all. And let's say we know the area is 0.6. We're asked to find the z-score. Let's make a drawing. It's a standard normal, so our mean is 0. And the area is 0.6. Remember that this area up to the mean is 0.5. So 0.6 is a little more than that. So we're going to be about 60% of this. That's the area that we're given. And what we want to find is the z-score that correlates with that area. This tells me that the z-score is going to be positive. So if given that drawing, it helps me out. But the biggest thing that I see students do is confuse the area with the z-score. So you really want to understand that this is 0.6, not this. Let's take a look at how we find this z-score first with the table. We're working with a value greater than 50%. Our area is 0.6. So we're going to look at this part of the table, and we're going to look for an area in here that is as close as we can get to 0.6. So if we take a look up in here, this is very close. It's 0.0013 away. This is a little bit further away. It's 0.0026. So this would be the area that's closest. And therefore our z-score would be 0.25. Now let's find this z-score using Excel. And this is the function that I want on Excel. It's the inverse of a standard normal. So let's take a look. We're going to use Excel to find the z-score when we know the area is 0.6. Press equal, start typing in normal. And there are two inverse normal functions. One is for the standard normal, which is the one we want, and the other one is for any normal. So this is a standard normal. It's an inverse operation. We're finding the z-score when we know the area. So we press that, and it's asking for probability. That's the same as the area, 0.6. And our z-score will be 0.2533471. It's a more exact value of the z-score than when we use the tables. In our second example, we know the area is 0.1. We're finding the z-score. Mean is here. So 0.1 is a very small area. It's less than 50%, so it's going to be somewhere over here. So this area is 0.1. I want to find the z-score. I know that the z-score should be negative because it's to the left of the mean. Again, let's find this using the table as well as Excel. This time we're looking for a z-score that corresponds to the area of 0.1. Now, that's less than half, so we know that we should be looking at negative z-scores. So let's take a look at a number that is as close to 0.1 as we can get, which is right here. That's going to be as close to the areas we want, so our z-score is negative 1.28. Now let's use Excel to find that same z-score. We're going to press equals, and we're going to look for norm S inverse. We're going to enter the probability of 0.1, and our z-score is negative 1.2815516. It's very close to the value we obtained when we used the table. However, this is more accurate because we used an area of exactly 0.1. Let's take a look at any normal distribution. And the example we're going to use is IQ scores because we do know that it's normally distributed with a mean of 100 and a standard deviation of 15. So an example question might look like this. 75% of the population fall below what IQ score? 75% is the area. And we're trying to find X. What IQ score gives us 75% of the population. If the area is 0.75, we know that that's going to be over here somewhere. So this area is 0.75. We're trying to find the x-score that correlates with that area. We can either use tables or Excel. And if we're going to use the table first, but understand that when you use the table, you will get the z-score, not the x value. So we look for the area closest to 0.75, which is right here. So our z-score is 0.67. Now we have to convert that z-score to an x value using our formula. From the table, we got a z-score of 0.67. However, we want the x value, the IQ score. So let's convert our z-score to an x-score using the formula we learned previously. Plugging in 0.67 for z, and 100 is the mean, 15 is the standard deviation. We can solve for x. Let's multiply both sides by 15. And then add 100 to both sides to get 110.1. So the IQ score that 75% of the population fall below is 110.1. Let's confirm that with Excel. Note that we're now working with a normal distribution, not a standard normal distribution. We've got the area of 0.75. From the tables, we were only able to find the z-score, and then we had to convert to the x value. With Excel, it tells us the x value. So equals, start typing in norm, and we're doing the inverse norm. So it's going to ask us our probability, which is 0.75, the mean, which is 100, standard deviation, which is 15. So our x score is 110.117346. Next example with IQ scores could look like this. 10% of the population have IQ scores of blank or higher. So 10% have IQ scores of some value or higher, which means we're finding the area, or we're given the area to the right of some x value. So that area is 0.1. So that means we're finding the x value where 90% of the area is lower than that. So we're going to use an area of 0.9 to find our x value. Again, let's do it using tables and then confirm it with Excel. We're now looking for an area of 0.9. The closest we can see to 0.9 is 0.8997. So our z-score corresponding to that will be 1.28. So here's our formula for converting z-score to an x-score. In this case, we know the z-score and we want to find x. So let's plug in all our values except for x. And let's solve by x by first multiplying both sides by 15. Then let's add 100 to both sides. And when we do the calculation, we get an x score of 119.2. Now let's find this x value using Excel. Again, when we're using Excel and we have a normal distribution, we can get the x score, not just the z score. Equals norm inverse. Probability is 0.9. Mean is 100. Standard deviation is 15. And our x value, or x score, is 119.223273. So 90% of the population would have an IQ score of 119 or lower. This value is very close to what we obtained when we did it with tables, but understand that when you use Excel, you get a more exact answer. And that's how you find the X or Z score when you're given the area.